what we're going to look at are, well, I'll show you. What's the difference between those two? Ooh, what is it?
Sequence 2, it keeps on going. The sequence 1 stops at 15.
Okay. So this would be called finite. Because why? It ends. And this would be an infinite. Because it dot, dot, dot. Very right off the bat, that's how you tell the difference between a finite or an infinite sequence. Okay. The dot, dot, dot tells all. Excuse me. Now, what if I wanted to write a rule that shows how that sequence was developed? Well, here's what happens. These parts here, those parts are called terms. Okay? Oh, I had something. Look at that. I forgot that was there. Anyway. So these are called terms. So term 1, we usually say like n sub 1, n sub 2, n sub 3, and so on. So the fifth term. Well, it's the first term is 3, 6, 9, 12, and then 15. How are you generating each of those terms as a sequence? The first term is 3, the second term is 6, the third term is 9, and so on. How are you doing that? It's some number times 3. You don't want to say adding, okay? You don't want to say adding in this case because if you start with 3 times n, if I start with n equaling 1, that would be 3 times 1, 3 times 2, 3 times 3, so on. If I'm doing it in terms of addition, if I say it's going to be 3 plus 1 for the first term, wouldn't that be 4? The second term would be 3 plus 2, which is 5. So, see where I'm going with that? Now, this is where it gets a little bit goofy as far as how do you figure out if you're correct. Well, what's nice is that you guys all have a calculator. You all have the calculator. And you all have a y equals button. What you can do here is you can put in what you think the equation for the sequence is and the y equals, and then just look at your table. If the table matches the numbers, you know you're right. If it doesn't, you've done goofed. Try it again. All right. That's all it is. 3x. Yeah, the x, and they use a bunch of different variables for it. They actually use lowercase I, which is just silly. They use the I value, a little imaginary I value. I don't know why they use I. They're just stupid. So if you go to your table, and you'll see how the pattern works itself out. Okay? Are we okay with that? It's a really nice way of checking to see if you're writing the terms out correctly, especially for some of the goofier sequences that we come up with. All right, it's a nice way to check yourself. But we might as well get the doofuses out of the way. The greatest picture ever.
Oh my god.
That's awesome. Seriously.
My favorite one was Hannah and Hickey, where they put Kate's face on, like, do you remember that? Where Hannah's like that, and then they, like, photoshopped, like, Kate's face.
Yeah.
That was funny.
Or when we've done that to Caleb's face on volleyballs and stuff like that, when his sister's hitting it. Spell your name is hard.
So look awkward. You just see that one?
How's that stadium?
It was awesome.
That's really cool.
Really awesome.
That was the one where the minor league team plays, right?
Yeah. Sorry, I have to focus.
Correct. Cursive is hard.
Okay. Yeah, it was cool though.
It was freezing though.
Yeah, it was not very warm out over spring break, except for that one day. Tuesday.
Oh, you should Saturday?
The Tuesday was really nice. We took the kids to the Milwaukee
Saturday
Zoo.
was awful here.
You guys ever been to Milwaukee Zoo? Milwaukee Zoo.
And then it was like fine. And then it was like,
Alright, excuse me. So let's look at a couple different sequences and see if we can write the pattern out and write a rule of what's called the nth term. The nth term is what we talk about. If I want to figure out, if I have some sequence like we just did and we figured out the pattern was 3 times n. If I want to say what's the 15th term, I would just use n as 15. That's what it means by nth term. So if I want to look at one where it's negative 1/3, 1/9, negative 1/27, positive 1/81st, or 1/81, I got to figure out a way to write that in terms of some equation generated as first term, second term, third term, and so on. So a lot of times as you start to play around with these, if I put them vertically, sometimes it's easier to see what's going on. So first term is negative 1/3. Second term is positive 1/9. Third term is negative 1/27. Fourth term is 1/81st. It's going to be the fifth term. Perfect. You're right. It's going to be negative 1/243. But what's the rule? What's the reason that you're getting that? Yeah. Right. What happens here a lot of times is you start to see it as you're writing it out vertically. You might start to recognize a simple pattern that's going on. Notice that the signs are changing each time. Negative, positive, negative, positive. And you also, if you notice, it goes 3, 9, 27, 81. You might recognize it's 3 squared, 3 cubed, 3 to the 4th. So what you guys just picked up on is starts out as negative 1/3 to the nth power, where n starts at 1. Okay. Now, if this started at, let's say this started at 1, what would n start at? 0. Very good. Does that make sense? Sometimes you say that n starts at 1, and that comes more into play when we start writing in terms of what's called summation. And we'll talk about that in a little bit. Again, you can go in your calculator. If you throw that in there with parentheses, you'll check. You're going to get crummy looking decimals, but you should be able to just mess around with the decimals a little bit to see if you are somewhat close in your answer. Is that fair enough? Not too bad, was it? How about the next one? 2, 6, 12, 20. Child's play, huh? 2, 6, 12, 20.
Like I know what it is, but I don't know how to explain it.
Yeah, exactly.
All right.
Exactly.
All right, well, what's the fifth term? Third, okay. So the fifth term is 30. Everybody okay with that?
Yeah.
No.
Yes.
I have okay, yeah. Got it.
So you did 1 times 2 to get 2. 2 times 3 to get 6. 3 times 4 to get 12. 4 times 5 to get 20.
Oh, I was thinking
Oh,
like
like
that.
that.
I was thinking
Yeah,
like
it's like adding
6
4,
plus
adding
10.
6, adding 8.
Well, how do you write that out as far as?
No idea.
I don't know.
Yeah.
You're right. And that's how I would write it out. I'd write it out as n times n plus 1.
Okay.
Because you guys are right, because you're going up by 3, 4, 5, excuse me, 4, 6, 8, 10. But how do you write that in terms of some equation? I mean, you can mess around with your values, and there's more than one right answer to do some of these types of problems to get the nth rule. And that's the benefit of going back and forth and checking in that y equals table. That way you can see if you're right. Does that make sense? It's not like I don't take the calculator away from you on these things. I'll still make you have to figure it out, but you can at least check to see if you're right. Okay? So you just write it out. Excuse me. So the two differences that we look at, we have finite sequences, finite series. The difference between a sequence and a series is pretty darn evident.
There's no dot, dot, dot.
Between sequence and series, there's no dot, dot, dot.
No, between infinite and what's the difference?
Yeah, there's no dot, dot, dot.
Yeah, well.
What's the difference between a sequence and a series?
Oh, I didn't hear that.
The addition sign. A series is you're finding the sum of a sequence. You're adding everything up in the sequence to find the sum. What we use with series notation, we use something called summation. Sigma. It means the sum. Okay? What are the sum of the values? Now, obviously, we can add up 3, 9, 12, 15, or 3, 6, 9, 12, and 15 pretty quickly. What happens if there's 30 of them? You don't want to do that. But you can use what's called summation notation. And there's a button on your calculator. But we need to know how to write it out.
I remember doing this back in 8th grade.
Did you guys do summation notation?
Yeah, we did. No, we didn't. Yes, we did. No.
Cooper, you're delusional.
But we either did this in 8th grade or in 7th.
You probably did a little bit of, you might not have done actual, like, write it all out, but you might have been told what it means. You might have, did you go from this to that?
I just remember we did some way where you were able to add a series of numbers
Yeah.
up by not doing
Yeah,
it.
we did that when we tried to do this.
Yeah, we didn't write it down like that, but we still we
That was
didn't.
the average.
No.
Well, finding the number in sequence.
No. Anyway.
No, I'm sure you guys probably did something similar. I mean, there's a bunch of different ways that you can do this stuff.
Maybe I'm crazy, but I just remember.
Yeah, you
are.
Maybe I just remember doing something similar.
No, that's fine. All right. First of all, what's the rule? 3, 6, 9, 12, 15. What's the rule? So, n times 3. 3n. Yeah. So we put the rule here. Where does n start? 1. First term is 3, so it's 3 times 1. So n starts at 1. And how many terms are in sequence? Where do you start and how many there are? So that's why I was saying a second ago, sometimes you might start at 0. Sometimes you might start at 1. You might start at 4. It depends, it all depends on what your rule that you come up with is. Because there are going to be more than one rule. Because there's 5 terms in the sequence. So if we wanted to figure that out, there's a button in the calculator to do so. Let's see here. If we hit alpha window 2. And you get that summation symbol. So the first thing you got to put in there is going to be x. Because that's your unknown. Move it to the right. Where are we starting this at? Oh, I accidentally went too far. We're starting it at, so put a 1. Go up. How many are in the sequence? Excuse me, how many are in the series, excuse me. And then we put our rule on the inside. And you hit enter. You hit 4 times. Obviously, like I said, it's really, really easy when you have a small amount to just kind of do it by hand. But anything that starts to get larger, there's a button. Okay? There's a button. All right? Everybody find that button okay? Off of window 2? Okay. Try another one. So let's do both of these in terms of summation notation and then find the sum of them. So So the first one we have 5 plus 10 plus 15 plus blah, 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 plus 100. That blah, blah, blah means the pattern continues between 15 and 100. Everybody okay with that? So, what's your rule? 5n. Good. So we started out with our summation symbol, sigma. Where do you start? At 1, n equals 1. And how many terms will be in that series? 20, good. Put in your calculator and hit enter. And what do you get? Here. Okay. What about the pattern on the next one? 1/2 plus 2/3, 3/4. Yeah.
So series are used to describe
Series, you're adding up a sequence. It's the sum of a sequence. 1/2, 2/3, 3/4, 4/5. What's next? 5, 6, 6, 7. So what's the pattern? Good. X over x plus 1. Where do you start? 1. So we know the rule is going to be n over n plus 1. And it's going to go from n equals 1 through, well, what does dot dot that mean? Infinite. Could I have written that differently? What if I said it started at 0? Then the top would be n plus 1, the bottom would be n plus 2. So there's more than one way to write these out. Yeah, Vince.
How do you put infinite in the calculator?
Oh, I don't know. Is there a button?
Go to the catalog.
You can't, you're not going to be able to sum this
Nope,
series.
there's nothing.
Okay.
That's how you write.
So they just
Yeah, because this one just is write it out in notation.
Independent.
Now, what happens is you will be able to find the sum, bless you, of an infinite geometric series. There's a formula for that because it's approaching a value. But we'll talk about that as we get to it. But for something like this, you just write it out. There's no answer to this.
Of course there's no answer.
When adding up cancels.
What's that? It depends on the sequence. Depends on the series. Like I said earlier, we will talk about infinite geometric series, and there is a formula to calculate it because it's an exponential growth, exponential decay problem. So things are pulling away, and you're approaching values. You can't. That was the whole point. It just write it in notation. That's all. This one this one if you press the button because you can. That one you can't. Did I tell you guys where infinite symbol came from?
No.
Really?
Eight sideways.
What does that look like?
Fish.
Racetrack. Mario.
infinite side.
This one looks like.
It looks like a chip.
It looks like a Pringle, doesn't it?
Yeah.
Oh, what Pringle?
Pringle.
Like a
Oh,
Pringles?
Yeah.
Come in the cylinder?
Oh, okay. I'm like.
Do you know why Pringles are shaped like that?
Significantly good.
No.
Stack. So you put them on your tongue.
The guy that invented the Pringle was upset that he would always get broken chips. So he developed a shape. It's called a hyperbolic paraboloid. The shape of a Pringle is a hyperbolic paraboloid,
Okay.
and that way they are stackable and less prone to cracking, because isn't an arch a stronger shape than a straight line?
Wow.
Wait, so there was no infinity sign before the Pringle?
There was, but the shape of a Pringle is called a hyperbolic paraboloid, and that's why it was done. Sir?
Like the bottom half of Pringles, well not bottom half,
Yeah.
the bottom
Now we
about
can just see.
third of Pringles are always like powdered by the time you get
It's because you don't have.
there. Wait, is there supposed to be like an infinite button? Because no, look,
Yes, they're messing with you if they're telling you this. There's no infinite, by the way. There's seriously, there's nothing. There's no infinity. You know what? Notice all you have to do is this. When you're putting it in your calculator, turn it sideways and write 8, and then turn it the other way and see what happens.
Yeah, whoa. You never told us where infinity came
I
from.
like.
No, I'm just saying that the symbol, what the symbol looks like. It looks like a Pringle.
That's not where it came from.
Where did that symbol come
No,
from?
I don't know where infinity came from. That's not, I'm telling you where Pringles came from. Anyway, so a couple. There, yes, sir.
So in that case, I was just a random number.
No, because it's imaginary. It starts with 9.
So in 62, it's not.
No. Shh. Guys, real quick, there is one last little bit in this section that they throw the value I there. I just stands for X, and doesn't matter, just some variable. I don't know, but here's the other thing. There is absolutely no reason as to why we need to know any of these. Okay? Because there's a button on your calculator. There's no reason why we have to know how to break down x squared into, oh, it's x times x plus 1 to 2x plus 1 all over 6 as I sum it from x equals 1 to however many times. It's dumb. There's a button on your calculator, out the window too. We don't even bother with this anymore. Wish I could say the same. So again, don't worry about that because you're going to have a button. Okay? There are special patterns. They really don't do much for us in the long run. We don't have to simplify. We're not breaking stuff down. We're not trying to factor any of this junk. We're just using it as a summation button. Okay? So let's look at.
Doesn't that mean that it's our time?
Aloha. Let's write the rule. Excuse me. I will say one thing. A lot of times when you're doing this stuff and you see signs that are alternating, probably have a negative thrown in somewhere. You might have a two things being multiplied and so on. But in this case, it's probably pretty obvious what the next term is going to be. 25. So we need to figure out how in the world are we going to write first term was -5, second term was a 10, third term, fourth term was 20. But we know that the fifth term will be -25. So we have to figure out how we're going to write this so that way we can have a generic rule. Everybody agrees that we have multiples of 5 times n.
Correct.
Negative n. 5 times negative n.
Oh.
So 5 times negative n. If I do that,
It's always negative.
it's always going to be negative though.
What did you say?
He said bullshit.
Shit.
Uh-huh.
He said Pringles. Chip.
Mhm. Bullshit.
Stop.
Bullshit.
So this is where it comes around where it's not going to be 5 times negative n because that's not going to make it work. So this is where you start messing around with how do I get this to work? So what do you think you're going to use? Exponents. How do you do that? Now, if you're using exponents, if you're going to use exponents, wouldn't it's 5 times -1
Yeah.
because
Oh man.
You see how that works? Because you have 5 to the negative 1 to the first power is negative 1. Negative 1 squared is,
Five n to the negative
Yep.
5.
so it'd be 5, what was it?
5n.
What is it?
5n times would make it times negative 1 to the n would make it positive negative. Why not?
Because you have to do the.
Yes, that's what you're saying. So it'd be 5, you're saying 5n times negative 1 to the n? Well, let's check it. And that's what a lot of this is.
Eric was trying to tell me that it's -5 to the nth power, and I just told him why it's.
Negative 5, yes, no, because if it's negative 5, it would be negative 5, and be negative 25, and so on. So 5x times, was it negative 1 to the x, you said?
Yeah.
I'm getting all negatives
Oh,
because of the.
yeah, because you did negative 1 to the x inside the parentheses.
Oh, yep. So I have to do negative 1, parentheses negative 1. Let's see here. There you go. So it's a lot of messing around. It's a lot of messing around with, like you said, the PEMDAS, your order of operations, trying to decipher how do you make it work. It's a lot of trial and error. And you probably saw a little bit of that yesterday, guys. You probably saw a little bit of that yesterday with the arithmetic stuff. Although it is a little bit easier to distinguish them when you know that it is arithmetic. There is a common difference. Or if you know that it's going to be a geometric when we have a common ratio. Okay, so those are a lot easier. This stuff is going to be a little bit goofy. It'll probably take a little bit of time to work yourself to write out the rule. But a lot of it is also trial and error. And it's a lot of messing with the calculator, playing around with the order of operations, making sure you have your parentheses in the right place. I forgot my parentheses. Yes, sir?
Why did you say that some of the other stuff that we were working on is ridiculously easy, but you didn't say that this is? Because this actually is and the other stuff isn't.
Yeah, that's pretty easy.
It can be. I think this first section, excuse me, the first section can be a little bit goofy because your mindset has been so, there's a process, there's something to do, follow the process, expand upon it. Whereas this, what's the rule, how do you develop it, how do you write it? So there's a lot more thinking involved to this as there was some of the other stuff where you were just kind of like, okay, 2 pi over 3, that's up over here, reference angles, that no, because you did the same thing each time. Here, it's kind of like simplify, verify, where there's more than one way to do it, but at least there's numbers. Okay? Does that make sense? Do one more?
Mr. Murphy,
Yeah.
so I typed in the equation that we just did for that.
Yeah.
And it, like, why wouldn't it graph it?
Why won't it graph it?
Yeah.
Oh, it could graph it.
It won't graph it, like,
Do you have,
like,
in your windows all that stuff, that's all.
Oh, that's it.
Oh, it's your plastic. The graph was first.
But you know what's in
I said it's a good feeling.
You know what's even better than having this brand new? Should have every money for you. I'll bring it tomorrow.
If you remind me of those types of ones, because I got couldn't you not do that because it would be a fraction and you can't get square root to basic?
I try and read a book a day.
He did a video of just reading a book and then he's like, have someone read it.
Guys, come on, you got one here. Try it.
That's
No idea why it's not showing up. It's weird.
Does it graph other stuff?
It should graph, but I don't know why it's not doing it. What is it? 10 to the end?
No, I think it's
So if it's 10 to the end, that means it's 10 to the first.
No, it's 10 to the end.
There you go, Eric.
Because you're starting that first term.
So
Your first-
that's always going to be considered first term, so it doesn't get confused up.
Think of it as, if this is my first term, how do I make 10 to the end turn into a 1?
Is there gonna be something?
I'm sorry. Guys, please.
Is there going to be something where that's not the first term, it's going to be dot, 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 and 1, 1?
Yes, and we'll get to that. But here's the thing. When we get to something like that, it actually is easier because there's generic formulas that'll allow you to figure out the differences or the rates to come up with the common, to come up with the rule. It is much, because it's back to plug and chug in an equation. Whereas this stuff is a little bit more abstract because you have to develop it on your own. Whereas the other stuff, I'm going to give you a specific formula, you substitute in these values, it's going to generate something else. So it goes back to the idea, there's a process, there's a formula, solve for x is basically what it is. Is that clear? Does that make sense?
Yeah.
So yeah, you're winding up with the 10 to the n minus 1. Okay? Carlos. Why was that one?
Because when you're getting in between numbers, it's fractions, and since you're taking a negative from here, it's like, because this is -1 and it'll graph both numbers.
Oh, that's right. Yeah, I understand. And you might have to try a setting to make it go.
I don't think Mr. M, is it 929 odd?
Yes, both of them are odds, guys. Both these guys are odds. That way you can check your stuff, see if it's Use that calculator. Use your y equals table to help figure out if you're doing it right. That's the trick. It's a lot of trial and error for some of these. I'm not going to lie, you're not going to like a couple of them because they can get kind of goofy. But try them, okay?